Hi guys, how are you doing? I do really enjoy this today's. I feel like I'm in a really special support group. Like, hi, I'm Marina and I'm data scientist. Hi Marina, we understand you, cool. And I'm working for Grey Cortex. We are doing cybersecurity there. And this is really like trying to make world a safer place. And cybersecurity is like playing cat and mouse, and like a story's never-ending story. As machine learning tools becomes more popular, becomes more available, hackers tools becomes more sophisticated, and that's why we have to use more and more complex model to detect it and to predict these actions and so on. And what I have realized that making world a safer place, it's not a rocket science, it's a data science. And what we're doing, as a scientist, I'm curious and I like asking questions and finding an answer. And first question was, what is actually so complicated about cybersecurity as an application for machine learning tasks? And in this section, we will discuss, of course, data, models, and some special requirements which come in from these fields of application. And after that, we will go to the most interesting part, which is how to build machine learning spaceship for detect more old and persistent security attack like SQL injection. And after that, we will talk a few words about how to make this model actually fly, how to deploy this model, how to make it work in the real world. So let's start. What is so complicated about cybersecurity? First thing, of course, it's data. We analyze, we get data from the network traffic, which means that data is semi-structured. It goes in sequences, and these sequences contains value of different types, and it's really specific because each network protocol use its own data structure, its own specific information, and we need to capture data, parse it, and structure it before we can do any analysis on it. And second thing I would like to mention today, it's labels. If you want to use some supervised model, you usually need to label data first. So you need to understand which is actually attack and which is normal behavior, normal data. That goes with some complex thing about this. Because you need, here we have a next question, where to get these attack samples. Nowadays, happily, exist pretty much tools like penetration testing tools and honeypots and whatever that we can use for this task. But with supervised models, often the problem is unbalanced data, because for trained supervised model, usually you need training set about equals with a number of positive sets and negative data. And you can think that getting these attack samples, it's more complicated part of this. But actually, sometimes, given benign set is more complex task. Because if you think about it, how many actually unique requests to a single application can you send? Not that much, actually. And to solve this problem, we use data generation and extrapolation tools. Okay, and next thing, it's a well-known problem of machine learning model that it's pretty lazy. So it get more obvious, let's say, information from the entire data. What I mean, for example, if you would like to train your cat or dog classifier and use mostly white cats images for training and black dogs, for example, most likely your algorithm will fail with trying to detect white dog, because most likely your algorithm decide, okay, it's white, so it's cat, because I mostly seen white cats. But what would happen if you will decide to detect, for example, red cat? I don't know. This problem goes with understanding that as data distribution changes, the accuracy of whole algorithm also goes down because of this problem. That's why we use actually transfer learning, right? But if for text processing, for example, or for images, we have plenty of tools, for plenty open data set to deal with this, to pre-trained model and whatever. No one really wants to share their own private network data. It's kind of problem for us. Okay, and now let's go to the method that we use. It's clearly goes from the a priori information that we have. So if we know what to find, we normally use classification. And but it's not really useful in real life, no? Because if we know how a text looks, okay, good, but hackers are really creative in this in creating new tools, new attacks, and whatever. So we need to be able to detect something that we have never seen before, and that comes with task like anomaly detection. And here is the next question: when the anomaly is an anomaly, actually, look at this nice picture. One of these guys definitely not like others, but who? If you look to this tall guy on the left, I mean this, he definitely looks like an outlier. If you decide, if you look at it like in time series data, it's definitely like a spike. And maybe this is anomaly, this kitten is an anomaly. But definitely he is an anomaly like in terms of content analysis. But actually attacker this meerkat because he has a flash stick in the pocket. Okay, anomaly detection actually works pretty well for security application, but you need to be really careful during training this model to not train the some attacks as a normal behavior, as a normal actions. That's why we use a combination of supervised and unsupervised and semi-supervised learning to get the good product. So our solution is a holistic combination of different models, like prediction analysis, flow analysis, and rule-based analysis, and so on. Everything is connected to everything. And we input network data to this, and after processing and analyzing, we get network visibility, security events, network statistics, and risks. And next, think about cybersecurity is a speed. For example, for 1 gigabit canal, channel, sorry, we have about about 1.5 million packet per second to analyze. And user don't really want to wait a minutes while your model get that prediction, because user want to just click the link and get the result immediately. And as you've seen before, analysis tool is really a combination of models. So during the, developing one single detector, you need to keep in mind that it will be part of bigger system, and so you need to use computational resource really wisely. And next thing, last thing, yes, it's false alerts. It's a real headache, since it reduces trust to your security tool in general. Because if your application, security application, rise alert too often, and where it's nothing serious, actually, users start to ignore it, and it's cause a problem when it's real some malicious action. So now we have a big picture how it goes in cybersecurity. We know that it goes from the special requirements from performance, for models, from data, and it's really sensitive for false alert. Congratulations! Now we can move to the next section and see how actually develop the model. Yes. First, what is actually SQL injection? And in far 1998, Jeff Forrester found out that putting special commands to SQL to the query may force server reveal information stored on it. And as a good guy, he reported to Microsoft about this problem. But Microsoft said that it's nothing to worry about it, so no one will use it, and you should just forget about it. But hackers said, SQL injection. And how it actually works. For example, you would like to log into some web page, and you just put your username and password to login form, and it will be present in query like that. Application server will transform it to the database request like that, and after authentication passed, you will get your data as a HTTP content. Now let's suppose you embrace the dark side and would like to perform some attack like SQL injection. Here you put these command characters after username, and everything after that will be ignored by server. And this equation 1 = 1 always will return true. So authentication will be passed anyway. So you can get any data from the database using this simple trick. Why SQL injection still so efficient and popular? It's so simple. There are plenty tools that should protect database from this type of attack, like intrusion detection system, web application firewalls, and so on. But these tools usually are rule-based, so it just learn these special characters, this signature, and try to find these matches in queries in network data. And for example, requests like that will be probably blocked by web application firewall because it's like known combination of symbols. But there are plenty tools how to bypass this kind of tools using multiple commands, signs, mathematical, logical equation, and so on. So, and there is no way how to put everything in the signatures. So what can we do? Let's try to apply machine learning to this task. As far as it's more, it uses more abstract information about query than just sample matching. And our approach can be described like this: big, bigger, and the biggest. First, we consider this query as a string and did some string analysis. We get some features out of this, like countable parameters, how many parameters actually in query, how their order. Then we get lexical parameters like values ratio, letters ratio, digits ratio, and so on. Then we analyze keywords, which is special SQL commands, words like select, where, from, and so on. And also we count some punctuation symbols, because as you can see before, it's really often used for obfuscation. So then we use a scikit-learn library to create the models like SVM. We try SVM and play a bit with multi-layer perceptron. Okay, then can we do something else? Of course, we try back of words. So we get this feature. We consider this query as a sentence and extract some words and create a dictionary of unique words in our query, from our queries, from our data sets. But using whole words, normal words, like from normal human dictionary, created too long and too sparse feature vector. That's why we decide to keep only keywords, and remaining we split to character bigrams, as you can see here. Then we apply two techniques to create vectors. First was count frequency, which just count how often this bigram appear or keyword appears on query. And second was TF-IDF, when we use also weight, how it's really important, this particular token to our task. And then we also play with some machine learners, multi-layer perceptrons, and get a model like that. And what next? Okay, of course, try some sequential model. Don't just count how often these bigrams appear, that also keep the order how it goes, because it really can be important for us. Of course, we use the same bigrams and keywords vector and put it to embedding layer. I don't think that it's necessary to explain how it works here, because I guess you heard about it a lot. And we tried two models, two much more often used models for this task, like LSTM and GRU, and playing with hyperparameters as well. So the result was really surprising, because we got almost 100% of accuracy almost for all models, and this is a result for validation test, not for training. And here, the question, the trade-off between complexity and accuracy appears, because do we really need to destroy the planet to get rid of SQL injection? I guess no. If you look at this table more closely, you can see that a simple multi-layer perceptron works 200 times faster than sequential model. That's why we apply this to our product, and it works like that. Okay, now we are ready to the next question, to the last question: how to fly this spaceship. And let's look at the bigger idea. First, everything starts with an idea, or customer needs, or business requirements. And after that, we study this problem. What can we do actually? And we create our vision of this on this problem. After that, we run this data science cycle with data collection, data transformation, creating pipelines and filtering and stuff like that. After that, we create models and test, adjust hyperparameters and so on. And after the validation result will be good, we can deploy it to the product and ta-da, give the result, achievement. But it's not actually the end, because we need to monitor how it really works in big world, in the real world, how it works with customer data, how it react on data changes, and so on. And this feedback allows us reduce false positive flare rate, get some better result for performance, and be more sensitive to customer needs. And now we can summarize that we know something more about how machine learning works in cybersecurity field. We know how to build spaceship and how to make it fly. Thank you for your attention, and now your turn to ask questions.
Do you have questions to our speaker? Okay, no questions. So maybe you'll be able to catch our speaker.
That one.
Oh, there's one. Okay, sorry.
Okay, thank you very much for the interesting talk. I just wanted to ask, maybe I misunderstood something, but how did you finally get the data set all labeled, both for evaluation and for training, that is balanced and so on? Big enough to get a precise accuracy and so on the testing set.
Yeah, probably I missed this part. Thank you for question. Well, we did try a set of penetration tests in days, let's say. So we create some laboratory, let's say, for some victim applications that we will attack, and we attacked, and using different penetration testing tools, we was able to get some data from it, from logs files, actually. And after we had the idea how it actually goes from this penetration testing tools, we were able to put it to data generator and generate some more samples. So we was able to get about 600,000 samples total. That after that we split it, and for testing, validation, training set, of course.
Okay, so thank you so much. There's going to be a coffee break, so if you want to talk to Marina about the security and other stuff regarding the talk, feel free. Okay, thanks a lot.